Okay. So when we're doing a quadratic, make that a little bit bigger. Now, quadratic function is have this form. Y equals to x squared plus bx plus c. And when you're graphing it, you basically got a problem. And it's either go like this, or we could have something go like this. Now, one thing here is this is called the vertex. And also we got vertex here. Okay. Now, this is called the leading coefficient. The leading coefficient tell us whether or not it's called the opening up, or another way called is concave up. It's concave up, so the opening is towards up, or the opening down, is also called concave down. And that has to do with the A here. If A is positive, we got concave up. If A is negative, concave down. Now, if you're not quite sure, you can always try this function, y equal to x squared, and also another function, y equals to negative x squared. Now, if you graph this function, you can see that they're going to be like this. And if you graph this function, well, you basically get some points. Like, for example, if you want to say this s y, 0 will be 1, 1 will be 1, then 2 will be 4, and 0 is our that's our axis of symmetry. So you can see that it's actually moving up. On this one, if you got x, y, 0, you got 0, 1, you actually get -1. 2 is -4. So actually, if you graph it, you're going to get something going down like this. Good? Yeah, we good? Okay. So by checking this two functions, you can see that when the leading coefficient is positive, is up. When the leading coefficient is negative, is concave down. Now, we also have a couple special points. We know the vertex point, very important, and we had something called the vertex formula. Now, vertex formula, we call this point, give a h comma k. So our h is the x-intercept, is h. K is the y-intercept, is k. And we have a formula for that. H equals to minus b over 2a. And k, k equal to 4ac minus b squared over 4a. So that's our vertex formula. Good. And we also have a very important point is this. This is the we call that this is the roots of the function, or the roots of the function. Sometimes you also call the zeros of the function. And because at this 2 point, y is equal to 0. So we also have the formula for finding those 2 points. That's called quadratic formula. So we can see. And the quadratic formula give us this. We still have y equals to ax squared plus bx plus c. The quadratic formula is x equal to minus b plus minus b squared minus 4ac over 2a. And so now with those two formulas, this is a quadratic formula. And we also have, early on, we have this vertex formula. Okay, vertex formula. So with those, we can, when we graph the xy, the quadratic function, now we know the vertex is. For example, if vertex is here, and this is our h and k, and if it's greater, a is greater than 0, it's going concave up. And we can also find the y-intercept. Y-intercept, that's easy. Just set x to 0. So y-intercept actually just equal to c. So
Are you drawing stuff on your board?
yeah,
Oh, okay, I can't see it.
you cannot see my board.
No, I can see your board, but the last few stuff that I'm assuming you're writing, I cannot see.
Okay. Can you see now?
Is all your stuff left up that you had already wrote, or did you erase it all?
I moved to a next page.
Oh, okay, yeah, I still see all your old writings and stuff.
Huh. Everything in black.
Black with a little bit of red.
Okay. Yeah. Now I have the new page have all red. You don't see them?
Nope.
Huh. That's weird. Okay. Let me see if you can something change. Did that change?
Nope.
Weird. Okay. Um, let me see. Uh, yeah, you're here. You should be able to see it, Matthew. Can you draw something on the whiteboard?
I don't think I have access to draw on the whiteboard.
Uh, do you see the whiteboard? You see the whiteboard, right?
Yep.
And do you see on your left-hand side, you see all there's a menu there? You got arrow and the pen and shapes. And
Nope, I don't have that.
you don't have that. Mm.
Nope.
Here it does show you can see it. I don't know. Yeah. That's
Can you like close your whiteboard and like bring it back up, or
yeah, that's what I'm going to do. Mm. Now can you see it?
yep.
And our second page, oh, it didn't save on the, okay, so now can you see the second page? All in red.
No.
So you can only see the first page. That's weird. Okay. Let's try to,
But I did end up having that bar on the side that you were talking about with all the,
okay,
but no, I still couldn't see that.
that's weird. Um, Let me see if they have. Yeah, they actually get rid of hmm, okay. Okay, now can you see this?
Yep.
You can see it there. Okay, can you draw something?
No, I don't think so. I no longer have that bar on the side again.
No. Okay, let me do something here. Um, share. Oh, that's interesting. It does not allow me to do anything. Um, huh, all right. Okay, do you have the bar?
Uh-uh.
No. Now, do you see that there is your name there? Do you see that?
No, I can see your name though, but I can't see
You cannot see
mine.
yours.
Nope.
You see if there's something. Panel, Matthew. Hmm, that's weird. Um, okay. Anyway, but let's just keep going on this one. Um, as long as you can see this, should be okay. Okay, so we have a function. Let's see, y equal to ax squared plus bx plus c. Now we have two formulas which help us. One is a vertex formula, h is minus b over 2a. Then k is for ac minus b squared over 4a. And we also have the vertex formula. Oh, sorry, the quadratic formula. We got next to b plus minus b squared minus 4ac over 2a. Good. Okay, now given that, then we can just graphing it because we know where the vertex, that will be our h comma k. And we can find y-intercept. Y-intercept is when x equal to 0. So y-intercept is c. So let's say this is our c. And we can also find the roots of the function or the also called zeros roots, also called zeros of the function, which basically just y-intercept. Okay, so we'll find the y's here, then we find y's here, and we know the axes of symmetry is at x equal to h, because this is a vertical line when x equal to h. So everything is symmetrical around this line. So then we got 1 point here. The same distance, we'll find the other one. So therefore, altogether, we'll get something like that. Good.
Yep.
Okay. So we have that. Then let's see. We got some examples. From
Was this the same stuff we did last week?
right.
Okay.
Yeah. So basically, we're just still reviewing. So then we can have doing quiz. Okay.
Yep.
And there are going to be there are other things we learned in the past. Let me see if I refresh that. I don't know. I don't know if you can see this one. Can you see something here? I'm drawing something. Can you see it? Hello, Matthew?
Can you hear me?
I can hear you. Can you hear me?
Yeah, now I can. What were you saying?
Okay, do you see something on this page? I got a new page. If I
No.
Okay, so you only just see the first page.
Yep.
That's weird. Okay, if I go back to first page and see if you can see something. Um, do you see something here?
Yep.
Huh, that's weird. Okay. Um, so
Can you slide your screen on the whiteboard? Because I can slide over to one side.
I don't I can
Like
go
click.
down, but I cannot go to left or right.
Okay, yeah.
Do you
Because
see
I
it?
can, yeah, I can see
Oh
you.
yeah, actually I can. I can go there. Yeah, I can slide. Okay. All right. Well, let's just use this screen then.
Okay.
Okay. Um, Now we also learned so this is what we're going to test. We're going to test on what we just went over, and we're going to test and how to solve quadratic equations by factoring. So let's say x equals to 4x minus 5 equal to 0. Then we do make down this as 5, -1, and this is 1, 1, then cross multiply. We got x plus 5, then x minus 1 equal to 0, then x plus 5 equal to 0, and that will give us x equal to -5. And x minus 1 equal to 0, and that will give us x equal to 1. Do you remember this?
No, not exactly, but I'm writing it down.
Yeah. Well, if you go back, check on your previous homeworks, you'll see that. Good.
Okay. Yep.
And also you'll see, I have some recordings, actually, you can go back in and checking it. So this is something called solving quadratic equations by factoring. So basically what we're doing here is actually just find the XY coordinate. And there are basically two ways to do that. One is using the quadratic equation formula. Another is using the factoring. Okay, sometimes factoring will kind of save time. It's pretty easy to do. And sometimes you just cannot factoring. So the quadratic equations is always formula. Quadratic formula is always works. Okay, and we also learned something called completing the square. Completing square, for example, if we do exactly the same thing here, what we got is x squared plus 4x, and we move 5 to the other side, basically adding 5 on both sides. And then we're going to add something which is half of this number, 4/2, and square. Then on this side, we know 4/2 is just 2, so it's just 2 squared. And then on this side, we know 4/2 is 2, then it's become x plus 2 squared equals to 9. Then we square root on both sides, then x plus 2 is equal to plus minus square root 9, and that gave us plus minus 3. So therefore, once we got here, we got two solutions. One is x plus 2 equal to 3, and that gives us x equal to -1. Another is x plus 2 equal to -3, then x is -5. Exactly just like what we did here, -5, 1. Oh, sorry, this is just 1, not -1, and 1. Okay. Now, do you remember this? This is called completing a square.
Yeah, I remember this a little bit. Yep.
Okay. So basically, that's what our test will go over, is solving quadratic equations by factoring, and also solving quadratic equations by completing a square. And then we are actually we can use the completing square to derive the quadratic formula. So when we have a quadratic formula, we got ax squared plus by plus c equal to 0. Can you see it?
Yep.
And then we're going to divide by a on both sides. Now, the right-hand side just 0. On this side, we got x squared plus b over a, x, and we got c over a. So then, just like we complete a square, we move this over to other side. So that become x squared plus b over a x plus, oh, yeah, we'll add something here, minus c over a. Then what we add is half of that square, which is b over 2a squared. We're going to add the same thing on this side. And now on this side, of course, we got x plus b over 2a. And the other side, we got minus c over a. And plus, we got b squared over 4a squared. And if you want to combine this, we actually make that into a negative 4ac. So basically, we change this one to make the bottom 4a squared. And so we changed this into this. So then we can add b squared over 4a squared. Oh, make that a little bit to the other side.
Could you explain to me the half thing, like the b over a, half of b over a? Could you explain to me how you
Yeah,
get the half?
this is something called a complete square, like we did early on.
Yep.
Like if we go back here, come to here, you see that
Yep.
we add half the middle square, then we square the whole thing. And half of that, 4 divided by 2 is 2. Then this one we can write as this.
Oh, okay.
Good.
Yep.
Okay, so that is for us to make a square. That's why they go called completing a square. Okay, now we have this, then we on the left-hand side, actually we got this square. So basically this thing is equal to this. And the reason we do square is because now we can, if we do square root on both sides, then we can easily solve this problem. So this side is equal to top is b squared over 4ac. and over 4a squared. So now we're going to square root on both sides. If we square root both sides, then we got x plus b over 2a. And this side is going to be plus minus square root. Then this is a b squared minus 4ac over 4a squared. And that gives us plus minus b squared over 4ac over square root of the whole thing here. Now we know the square root of the bottom just gave us 2a. So we got this. Okay, good. Yeah, we good, Matthew?
Yeah, I'm just writing it down real quick. Yep, I'm good.
So now we're going to move this part over because we want to find x. So what we do is just minus that on both sides. So this side become negative b over 2a plus minus square root of b squared minus 4ac over 2a. Then we just combine them. Then we got negative b plus minus b squared over minus 4ac over 2a. Good? So now we got this formula. So that's how we got this formula is by completing a square. Okay.
Yep, I'm good.
Okay, very good. Okay. So now we're going to looking at a couple examples, just like when we did on the our homework. So let me close that and share. We got problem here. Algebraic workshop. Okay. All right. Okay, do you see it? Hello, Matthew? Okay. So now let's see. And here I give another way to find the k is by plugging h into the function. Because that's basically what it is the point is h comma k. So therefore, if x is equal to h, then y has equal to k. So that's why we have that. So sometimes, actually, typically this is a lot easier than using this. Okay, now we need to find the vertex point. This is a vertex formula. We also need to find the x-intercept, which is called the roots of the function. That is using the quadratic formula. And the y-intercept, that's actually pretty easy, just our c. So for this one, let's see what is our h. Our h is minus b over 2a. Our a is 1, b is 3, c is 2. And so we got 3 over 2a. So that's that. And if you want to find the k, if we use the formula, we got 4ac, our a is 1, c is 2, minus b squared is 2, then over 4a, 4 over 1. So that gave us 8 minus 9 over 4, so negative 1/4. And if you want to use plug in the function, then we got negative 3 over 2x squared plus 3, negative 3 over 2 plus 2. And this one is 9 over 4. And we got, oh, sorry, x squared. Yeah, it is that. That's 3 over 2. We got 3 minus negative 4. And this one is negative 9 over 2 and plus 2. So this will give us negative 9 over 4 plus 2. That will be negative 9 over 4. 2 just 8 over 4. So therefore, we got negative 9 plus 8 over 4, then give us negative 1/4. Good? Yeah, Matthew, we good?
Yep.
So now I'll just show you that we can have two ways of finding it. So we got our vertex at negative 3 over 2 and negative 1/4. And we can also find our y-intercept. Y-intercept is when x equal to 0. So when x to 0, then y is 2. So y-intercept is 2. Yeah, if you want to find the point is 0, comma 2. Then we need to using the quadratic formula to find the x-intercept, or we can just using the factorization, because at the x-intercept we got this 0 equal to x to the second power plus 3x plus 2. Now this is the quadratic equation. We know how to, if we do factorization, we got 1 1 2 1, then cross multiply 1 plus 2, 2 plus 1 is 3, so that works. So we got x plus 2, x plus 1 equal to 0. Then we got x plus 2 equal to 0. That gave us x equal negative 2. Or x plus 1 equal to 0. That gave us x equal negative 1. So we got those. So we got the points we need. Now, if we want to use the quadratic formula, then we just plug in. It's negative b, which is negative 3, plus minus b squared is 3 squared minus 4ac, 4 times 1 times 2, and bottom is 2 times 1. Then we got minus 3 plus minus 9 squared. 3 squared is 9, minus 8. We got 2, then got negative 3 plus minus square root 1 and 2. We know square root 1 is just 1, so it's negative 3 plus 1 over 2. Now, then, oh, plus minus 1. So if it's plus 1, then negative 3 plus 1, negative 2 divided by 2 is negative 1. And if minus 3 minus 1 is minus 4 divided by 2 is negative 2. So either way, we can either use factorization or use the quadratic formula to find our find our y-intercept point. Good.
Yep.
So
I just think the biggest thing that I'll need probably is the all the formulas, just to remember all the formulas.
yeah, you don't have to. Normally they will give you the formula as long as you know how to use it.
Oh, okay.
Yeah. So the key here is figure out what is A and B and C, because on here our A is 1, B is 3, C is 2. But for this problem, now our A is still 1, but our B is negative 4, then our C is negative 12. So that's something you have to be careful about. Okay.
Yep.
All right. Now, once we have that, actually, that can be pretty simple. We got we know our vertex is negative, which is basically minus 1.5, negative 1.5. So we'll be here. And our vertex is negative 4. So this is a half, and this is 1/4. It'll be here. And our y-intercept is 2, so will be 1 and 2. And our x-intercept, one is negative 1, and another one is negative 2. So now we have 1, 2, 3, 4 points. And we know our vertex, the axis symmetry is here, is right through the vertex point. So therefore, 1, 2, there is half, this 1. So 1/2 be here, then that's symmetrical. So will be here. And you can see that this is symmetrical to here, and this is symmetrical here. So the graph is going to be looking like this. Oh.
Where did you get 1/2 from?
Well, we know that this point is negative 1.5, right?
Yep.
This point, negative 1.5. So therefore, the distance from here to the center is 1/2, right?
Oh,
This
okay.
one.
Yep.
So I'm going to go 1.5, then find the point, which is symmetrical to this point. Again,
Yep.
yeah, it's helped me to find the symmetrical point, the point. So now we got 5 points, and then we just connect them and make sure that actually it's like this. There is, okay. And sometimes people join like this, then that's not correct. It has to have kind of the curve to it. Yeah. Good.
Yep.
Okay. Let's look at one more, which is this one. We know our A is 1, B is negative 4, C is negative 12. So our H then is minus B over 2A is minus B is negative 4 and 2A is 1. So negative, negative, positive. So 4 divided by 2 is 2. And our K, now if I using the function form, I just plug in 2. So that'd be 2 squared minus 4 times 2 minus 12, and that equals to 4 minus 8 minus 12. That give us negative 16, right?
Yep.
So we have this point is our vertex point is 2 and negative 16. And now the y-intercept is super easy. It just whatever that point is. So it's negative 12. And then we need to figure out our y-intercept, which using quadratic equation, that is minus b is negative 4, and plus minus b squared, which is negative 4 squared. And minus 4 is c. We got a is 1, c is negative 12. So that's why the sign very important. We got 2a. Our a is 1. So that gave us, this is 4, negative, negative, positive. Then we got negative 4 squared is positive 16. Then negative, negative is positive. So it's add 48 over 2. And that gave us 4 plus minus 16 plus 48. This give us 4 and 6, 64 over 2. And that give us 4 plus minus 8, because 8 squared is 64. So now we have two points. One is 4 plus 8 over 2. That is 12 over 2. That's give us 6. The other one is 4 minus 8 divided by 2 is negative 4 over 2, give us negative 2. Okay?
Yep.
So we got x equal to negative 2 or 6. So now we have that, then we can just graphing it, because we got all the points we need. And if you want to graph it, then we got is okay. And first of all, our vertex 0, negative 16. So if we say this is this is 2, 4, 6, 8, 10, 12, 14, and 16. And so this is our 2. So we got 1 point here. And we know y-intercept is 12. So this negative 2, negative 4, negative 6, negative 8, negative 10. So right here. I'm going to use different color. We got 1 point, 1 point. Then we know the x-intercept is here. So negative 2, which is oh, I put in the wrong one. This is a 2, so it should be on this side. Should be on this side. Good.
Yep. But I have one question.
Yeah.
For vertex, that was solving for H.
Yeah.
Okay.
H and K, that's the vertex.
Okay.
And then we know that we got negative 2, which is here, and 6. So 2, 4, 6. So our vertex, the axis symmetry is here. Okay, we got 2 points here, and you can see that this is 2, 4, this is 2, 4. So it's symmetrical, this 2 point. And the vertex point is right between those two x-intercept point. Good?
Yep.
Okay, so now we just need to figure out another point. We got 1, 2, 3, 4. Then we symmetrical. This is symmetrical to that will be here, right?
Yep.
And then we just then connect them. Yeah, this is kind of skinny, but can still connect them. So that would be that. Good?
Yep.
Yeah, so once we got to the graphing quadratic functions, that's where we see that we pull everything together. We have two formulas. The vertex formula, which allows to find the vertex, and also the quadratic formula allow us to find the x-intercepts. And of course, find the y-intercept is super easy. And that's enough information for us to graph a quadratic function. Yep, are we good?
Yep.
Okay, so all right, so that's we have for today. And I'll send send out, I'll email, uh, I'll email your mom, the section test, okay? Or unit test.
Okay. And that's due by the next time we meet, or when is that due?
Yeah, it's due by the next time we meet. So which will be 2 weeks from now, will be the April the 10th.
Okay.
Very good. Okay, bye,
See you later. Thank you.
bye.